Hello, you are welcome to Maths for Maths educational channel. We have been discussed number of questions in previous videos. The first question of part B of paper 1 of the model paper is like this. Asank, a member of a sports club, played for a cricket tournament and obtained an incentive payment from the club. He donated of 3 upon 10 his payment to his school for the development of the sports and 4 upon 7 of the balance to a home for elders. It is asked, state the amount he donated to the home for elders as a fraction of the original payment. State the total donation he made for his school and the home for elders as a fraction of the original payment. If the difference between the amount donated and the balance amount is 80,000, find the initial payment he obtained. Here in this third part, it is mentioned that this rupees 80,000 is the difference between the amount donated and the balance amount. So amount donated is he has donated to two places, and the sum of those two values, and the balance, the difference between those two amounts is 80,000. So we will discuss how to find the solution for this question. First part is state the amount he donated to the home for elders as a fraction of the original payment. The amount or the fraction he has donated to the home for elders is 4 upon 7, but it is not of the original payment, it is of the balance. So original payment for school is 3 upon 10, then the balance is 7 upon 10. This 4 upon 7 is out of that 7 upon 10. So therefore, to find that fraction, we have to do this type of calculation. 7 upon 4 of 7 upon 10. 4 upon 7. 4 upon 7 of 7 upon 10. So this is, we know, if the office there, you have to multiply it. So then 4 upon 7 multiplied by 7 upon 10. Then we get it as 2 upon 5. So this is the answer for the first part. Then second part, we have to find the total donation he made for his school and the home for elders. So that is 10 upon 3 upon 10 plus 2 upon 5. So we know easily to find this value of this one. The 4 upon 2 we can write as 2 upon 5 we can write as 4 upon 10. 3 upon 10 plus 4 upon 10. Then 7 upon 10. So this is the answer for the second part of the question. Then the third part, we have to find the difference. Now the amount donated is as a fraction, it is 7 upon 10. Then the balance is 3 upon 10. Then the difference must be 4 upon 10. This fraction of the whole amount he obtained is equal to 80,000. 4 upon 10 of the total donation is 80 rupees. So to find the total donation, we have to multiply this 80,000 by the reciprocal of 4 upon 10, that is 10 upon 4. Then you get 200,000. So that is the answer for the question. So here, incentive payment Asanka got from the sports club is rupees 200,000. Initial payment, this initial payment is the incentive payment, that is rupees 200,000. So that is in this question, the knowledge of fractions, simplification of fractions is very, very important to get the final answer. The question number 2, the question is, a local authority charges 20% of the annual value of a house as rates. The quarterly rates charged by the local authority for a certain house is rupees 650. Part 1. Find the amount of annual rates payable. Part 2. Show that the annual value of the house is rupees 13,000. Part 3 is, if the annual rates is paid before 31st January, a discount of 10% would be given. Find the amount of annual rates payable with discount. Now here, quarterly rates is given as rupees 650. Therefore, to find the annual rates, quarterly rates means 1/4 of the annual rates. Therefore, if the quarterly rates is given, to find the annual rates, the quarterly rates we have to multiply by 4, then you get rupees 2,600 as the annual rates. Now, this annual rates is calculated based on the annual value of the property. The local authorities do some assessment for properties or houses and decide some value as annual value of the property of the houses. Based on that annual value, the annual rate is calculated. So this is 20% of the annual value. So to find the annual value of the house, this value of annual house multiplied by 20 upon 100 is equal to 2,600. Therefore, to find the annual value, this 2,600 we have to divide by 20 upon 100 or multiply by the reciprocal of 20 upon 100, that is 100 upon 20. So this is how we have to find the annual value. Then when you simplify this 2,600 multiplied by 100 upon 20, you know how to simplify these type of value expressions. Then you get rupees 13,000. And if the rates is paid before January 31st, that means at the beginning of the year, for the whole year you have to pay the rates. If you pay it at the beginning of the year, the local authority decides to reduce the amount or giving a discount. Here they hope to give 10% discount. Therefore, if the rates is paid before January 31st, to find the rates that you have to pay, you have to multiply this 2,600 by 10% is reduced from the annual rates. Now, therefore, only 90% will be calculated for the rates payable. So, therefore, 2600 multiplied by 90 upon 100, because 10% is deducted from the annual rate. Therefore, only 90% is the amount we have to pay. Then it is, when you simplify this part, you get rupees 2340. So this is how we have to answer the question number 2. It is very easy. Only some calculations we have to do, simple calculations we have to do. And so then for the next week, question number 3. Using the Venn diagram given here, list out following sets. The Venn diagram is given. We have to list out number 1, A intersection B, number 2, complement of B, number 3, A union complement of B. That is the part A of question number 3 that we have hoped to discuss for this video. Part B is, from the universal set given above, an element is taken at random. Find the probability of getting, number 1, an element which is not in set A. Part 2, a multiple of 4. Now here the Venn diagram is given. The rectangular shape closed figure shows the universal set of set, and two subsets are there, A and B. They are intersected. So the elements for the intersection part is given as 1 and 3, and set A there are 4 elements, 1, 3, 6 and 10. B there are 5 elements, 1, 3, 5, 7, 9, and you know the universal set has altogether 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So this is very easy to answer the questions asked here. A intersection B is 1, 3. You have to include these elements in curly brackets. Therefore, the answer for the first part must be 1, 3 within brackets, within curly brackets. Then part 2 of the question is complement of B. Complement means which the elements which are not included in set B. So the elements included in universal set but not in B. So those elements are 2, 4, 8, 10 and 6. So we can write them as an order like this, but order is not so important. Only the elements should be important for the answer. So anyway, we have written the set as 2, 4, 6, 8 and 10. So this is the answer for the second part, or the elements of the set complement of B. Then part 3, A union complement of B. So union means all elements belongs to both sets. All elements in set A and all elements in set of complement of B should be included for the set. So all elements of A means 1, 3, 6, 10. So 1, 3, 6, 10 are there, and complement of B is 2, 4, 6, 8, 10. These elements also should be included in the solution. Therefore, we'll see 2 is here, 4 is here, 6 is here, 8 is here and 10 is here. And you have to be careful to write each element only once in the solution. So, this 1 and 3 we have to write as they are included in A, and some now 6 and 10 they belong to set A as well as the complement of B, but you don't write them twice in the list, only once you have to write. Therefore, that is the main thing that we have to keep in mind. So then the answer is 1, 2, 3, 4, 6, 8 and 10. So this is the part A of the question number 3. So we will go to part B. Part B is about probability. The first one is, first part is, they have asked to find the probability of getting an element which is not in set A. The element not in set A. The elements in set A is 1, 3, 6, 4, that is 6, 10. There are 4 elements, and not including to set A but excluding to set A, there are 6 elements: 2, 4, 5, 7, 9 and 8. Therefore, the probability of getting an element which is not in set A is, it should be 6 upon 10. 6 upon 10. So the answer for the part 1 of B part is 6 upon 10. And the second one is multiple of 4. In this set, in this universal set, only 2 numbers are there which are multiple of 4. Those are 4 and 8. Therefore, the probability of getting a multiple of 4 should be 2 upon 10. So the answer for the parts of B part of the question, that is part 1 of B part, and that is 6 upon 10, and part 2 of part B is 2 upon 10, 6 upon 10 and 2 upon 10. Those are the answers. So these parts also very easy to answer. So we have to understand properly the question, and you have to remind your principles of finding intersection, union, complement and probabilities. So then very easily you can get the correct answers. So question number 4 is under the theme of statistics. So the question says, a daily payment of the workers of a certain workplace is tabulated as follows. Daily payment is given in class intervals 500, 550, 550 to 60, 600, 600 to 650 and so on, and the number of workers also given according to those class intervals. We have to draw a cumulative frequency curve to represent the data above, and using the graph you have to find the median and the interquartile range of the distribution. So first we have to draw a cumulative frequency curve. We will discuss how to draw this cumulative frequency curve according to the given information. So the class intervals are like this, and the corresponding frequencies like this. Now here this 10 represent number of workers who get a daily payment within the range of 500 and 550. This is the range. So this 10 belongs to entire class interval. So we have to interpret it as 10 workers are there who get a daily payment within the range of 500 and 550. This 12 means there are 12 workers who get a daily payment of amount within the range of 550 and 600. So this is very important to keep in mind, that these frequencies are connected not only with one number of this class interval but with the entire range of the class interval. This is very important to understand the difference between the frequency and the cumulative frequency. Cumulative frequency like this. Here 10, so we can use in this class interval, we can interpret one thing. We told that this 10 is a number of workers who get a daily payment of amount this within this range, but this 10 indicates the number of workers who get a daily payment less than or equal to 550. This 10 is connected only with the upper limit of the class interval. This 22 means the number of workers who get a daily payment which is less than or equal to 600. So this 22 is connected only with 600 of this class interval, not with this 550. So this is the difference between the cumulative frequency and the normal frequency. So easily we can form an ordered pair to show the relation between these class intervals and the cumulative frequency. This 10 connected with 550, therefore the ordered pair is 550, 10. The ordered pair related to this second one is 600, 22. Likewise, we can make ordered pairs, and you can see an additional ordered pair we have taken as 500, 0 because the upper limit of the class interval which should be prior to this one must be 500. The frequency is 0 for that one, and cumulative frequency also 0. So to draw the cumulative frequency curve, this initial ordered pair also important. We can take it as 500, 0, and these are the other ordered pairs. These ordered pairs we can consider as coordinates of some points on a coordinate plane. So we can mark these ordered pairs as points on a coordinate plane. Before that we have to prepare a coordinate plane. So x-axis or the horizontal axis we have to mark for the numbers of the first number of the ordered pairs. So we have started with 450 up to 750, and the vertical axis we have to number up to 60, but here we have numbered it up to 65, but we have to be careful to take values only up to 60. So this one, the grid will be like this, and we can mark these ordered pairs as points on this grid. So then this is 500, 0, 550, 10, 622, 650, 40, 754, and 756. So these points we have to join with a smooth single curve. So it should be a continuous curve. So we have to draw it very, very carefully. So it will be like this. So this is the cumulative frequency curve according to the given information in the problem. Now using this cumulative frequency curve, we have to find the median. To find the median, now here I told that here there are 60 workers, So if they arrange in order, the 30th value should be the median. So to find the 30th value from this 30 of the vertical axis, we have to draw a line parallel to the horizontal axis to meet the curve, and from there we have to draw another perpendicular line to meet the horizontal line. So it comes like this, and the value here is 625. Therefore, the median value is 625 according to the graph. So then the second part is to find the interquartile range. So this distribution we can divide into 4 equal parts. So this 30th value, from this 30th value, this distribution divides into 2 equal parts. That first part we can divide again to 2 equal parts, taking margin as 15th value. To find the 15th value, we have to draw a line parallel to horizontal line from 15, and from there a perpendicular line. Then this value is the margin for first quartile. So then it is 575. It shows like that. And the third quartile, now the third half is from 30 to 60. The half of the middle of that one is 45. From 45 we have to draw another parallel line to horizontal axis. From there a perpendicular line. And then the value here is it's like shows like 665 or something like that. So we will see what are the values we have taken. So it is 665 here. That is the third quartile. Third quartile we name as Q3, and first quartile as Q1. So the difference between those two is 90. Now I told we have to divide the entire population of workers into 4 equal parts. That is from 500 to this place 1 part, from there to median second part, median to quartile 3 to third part, quartile 3 to the final one, fourth part. So these are margins. So for these margins, the range between these two quartiles is called interquartile range. So it is Q3 minus Q1, that is 665 minus 575, that is 90. So this is the answer for the question number 4. So we have to keep in mind the way of getting the column of cumulative frequency and the coordinates or the ordered pairs to mark points, and how to draw the curve, and how to interpret, how to use it to find the median and the quartiles. Then we can find the value of median and the value of interquartile range. So the question number 5, the question says, a frame of a window consists of 80 cm and 42 cm rectangular part. So the height is 80 and breadth is 42 centimeters. And a semicircular part with diameter 42. The diameter is 42 as shown in the figure. Part 1 we have to find, they ask what is the height of the window with the semicircular part, the total height. So that is very, very easy when you observe the figure carefully. Then second one is to find the area of the semicircular part, and third one is the total area of the window. Now first part is we told very easy, because from the height of the rectangular part is 80, you have to add another 21 centimeters to find the total height of the window. So it is 80 plus 21, that is 101. So that is the answer for the part 1. Height of the window is 80 plus 21, that is 101. So now the second part, we have to find the area of the semicircular part. Area of a circle is, we can use the formula pi r squared to find the area of the circle. If it is a semicircle, we have to use the formula as half pi r squared to find the area of the semicircular part. So it is half pi r squared, half times 22 upon 7 times 21 times 21. So we can simplify this part carefully, then we will get the answer as 693. So this is the answer for the second part, that is the area of the semicircular part. So this is the numerical expression that we use to find the area of the semicircular part, that is half times 22 upon 7 times 21 times 21. And to find to answer the third part, that is the total area of the window, we have to add the area of the rectangular part to this semicircular part to find the total area. So we can build up the numerical part like this, that is 693 plus 80 times 42. This is the area of the rectangular part. Then we get 693 plus 3360. When you add these two, you get 4053 square centimeters as the area of the complete window, that is including the rectangular part and the semicircular part. So this is the way of getting the correct answers for the question number 5. These questions, especially in paper 1, are based on, at the beginning also we told this one, these questions based on a list of learning outcomes called essential learning concepts, ELC, essential learning concepts. Essential learning concepts, there are 53. They have listed out taking the easier part of the entire O-level syllabus. Therefore, the questions in the paper 1 of any model paper or a government paper or the GCE oral paper, the questions are not so difficult or complicated. They are very easy. Only thing is you have to keep in mind the basic principles of mathematics principles and how to use those principles to find different values. So therefore, if you have a good practice of answering to paper 1 in different model papers, in the examination or the O-level examination, you will be able to answer the paper very, very easily. So next videos will be taken to discuss the questions in paper 2. So from the next video, we hope to meet you to discuss those questions.